Good morning, everyone. I'm very excited to introduce my superstar guest today, Mr. George Salazar, who is a chief engineer at NASA. And I mean, he has inspired me in so many ways. He is somebody who struggled in his student life but did not give up until he made it to NASA. He is working with human computer interaction projects over there, and a very humble and a very approachable person to know. Good morning and welcome, sir.
Thank you for having me. Good morning.
So, would you like to tell us something about what you do and what is your work at NASA?
Yeah, so uh, my main function is engineering related to human-computer interaction. So what does that mean? That means that I'm involved with systems that astronauts use that basically control a vehicle or control a camera, control lighting, anything that astronauts use for controlling something on the spacecraft, and they have to touch uh, and and uh, and use. That's my responsibility. The big one I have right now is what's called commercial crew program, which is working with SpaceX as well as Boeing. And soon I'll be working the human lander system. So in all those systems, there's humans involved. And anytime you've got a human involved, you have systems that have to be controlled. And so when we design those kind of systems, we have to be careful about how we design them because we want to make sure that the astronauts use it correctly so that they don't make a mistake or an error. And that's something that we don't want astronauts to encounter because safety is very important for NASA and astronauts.
Thank you very much. Indeed, you're right. But if I may add, in my experience, it's not only the astronauts. In fact, the astronauts are the smartest people, so it is expected they learn quickly. But every day, the way we are struggling with where's the right button, where did it go after locating it for the first time, I think for humans to get acquainted with technology has been a very big challenge, and it still is. So, I mean, I'll not ask you what is that one thing people should always consider a major factor for their interfacing. Instead, I'll ask you what is it one thing people should never do as UX designers to make life easier for the users.
Can you repeat that question again, please?
My question is, sir, as a interface designer or as a designer of a system which requires human computer interaction, what is the biggest mistake we make and we should stop doing it?
Well, I have to say that one of the biggest mistakes actually goes back to the training of engineers that develop these kind of systems. And I can tell you that when I went to school, I studied engineering, electronics engineering in my undergrad, and in my graduate, I studied systems engineering. But they talk very little about the human. And so when designers build things, they assume that the human knows how to use the system. And that's the first mistake. I think in the future, many engineers are going to start learning more about the human element. That's something that I got involved with on my own because I started to understand, why are we having all these mistakes? Not just in airlines, aviation, where airplanes crash, where ships collide with each other, and things of that sort. And it turns out that one of the fundamental factors is failing to understand the human limitations in terms of capabilities, in terms of performance. And so the biggest mistake that somebody's building a interface for a human is to assume that because the designer built it and knows how to use it, that anybody else can use it. That's not the way. And that's why we do a lot of what we call human in the loop testing with the astronauts, because we understand that maybe there are things in there that the designer overlooked. And the way we only capture them is by testing. And we tell the astronauts, here, this is the way you're going to use the system. And they start using it. But then, because of what we call mental models, how we see as humans, how this is supposed to operate, and the way one person thinks it should operate, the other person says, no, I think this is the way it operates. And so we have to think about the human element, as we call it, to understand how to design a system. So the biggest mistake a engineer can make is to assume that because he or she knows how to use a system, that the real user, whether it's an astronaut, a pilot, a captain of a ship, will know how to use it. That's a bad assumption.
You work at NASA. I'd like to know what has been your biggest, best experience of being associated with NASA.
Oh, I've had many. I have to say, it's just been an incredible journey. Um, One of my favorite was actually my first project that I was involved with, Space Shuttle, and that was developing a voice control system of the closed circuit television camera of the space shuttle by voice. And so that was my introduction to many things. My introduction to how to design systems for space, for the space environment, and also about the human element, because I was working with two astronauts that were going to use the system on space shuttle. And so it was just a very rewarding experience. It was my first time to go to the Kennedy Space Center and watch a shuttle launch, to get inside a space shuttle, to work with all the people involved with preparing a shuttle. It was just an incredible experience, and that's something I'll never forget. So it was my first one, and I for I have to say that it was a shocker for me because my supervisors probably saw something in me that I didn't, and they at a very early part of my career, they told me, "You're going to be responsible for this project," and I said, "Oh my gosh, what am I getting myself into?" But it's amazing what humans do when they're given a task and told what needs to be done. And so I was very fortunate to have been in that situation and work on such an incredible project.
Now, I'm really interested to know one thing. The first question you answered that your task or any a good interface has to understand humans and also factor in the human behavior while engineering a model. But then you just told us that to your own surprise, you managed to do things that you didn't know you could do, but your supervisors knew. And this is a great thing about human beings that their potential is so big, sometimes they themselves don't know. So, how do you, as a human computer interfacer, and at a top notch place that you are, how do you factor in human unpredictability on both the sides, good and bad?
That's a tough question, and we try to predict all the possibilities. In fact, oh my gosh, there's so many different analysis that we do. There's something called hazard analysis that deals with what if scenarios. What if this goes wrong? What if that goes wrong? What if you press this button? And so it becomes just lots of documents in terms of looking at all possibilities of hardware systems failing and what are the results of that. And so with that analysis, we look at ways of how are we going to control that if that happens. And so we go through this whole process of here's a hazard, here's a risk. How are we going to control it? How do we know when this happens? And we test for that to make sure that we really understand the hazard. Now, many times we just can't predict everything that is going to happen, and that's why that's the beauty of having humans in space, is because humans are very adaptive, humans are very creative, And so they come up with ways of solving a problem that they never encountered during training. And they see it there, but they know that they're going to need, this, they're going to need that, and maybe a little bit of help from mission control in Houston, Texas, to solve the problem. These are the things that we are preparing for when we go back to the moon and look at all the different possibilities that can possibly go wrong, and plan for them when we go to Mars. One of the biggest challenge going to Mars is the communications. It takes about 20 to 40 minutes in order for a voice signal to go to Mars and come back. And so, if there's a problem, they're going to have to solve it right away because they cannot depend on mission control because they're too far away. And so, we're going to need astronauts that are very creative, that are not very, let's say they're just not smart with books and stuff like that, but they're very smart with their hands. They're very smart, with coming up with a solution that they've never seen before. And that's what it's going to take to be on a mission to Mars. And if you ever read stories of early South Antarctica explorers in the 19th century, they they didn't know what they were going to encounter in Antarctica, and so they took some stuff and they were able to survive. Not everybody, but most expeditions did. And so the expedition to Mars is going to be very challenging. That's why we're going back to the moon to live and to learn and operate in a different world.
My second last question. Do you think that the technology where it's going, will it take over human beings or will it make human beings much more smarter because we have to coexist?
I'm sorry, the question is what now again?
I'm sorry. My question is that the way the technology is incrementally becoming part of daily life, do you think that the technology will at some point in time take over human intelligence, or do you think humans will grow more intelligent by using this technology?
I think it's going to be a combination. You hear about artificial intelligence and systems that think by themselves and all that. And I don't think we're there yet. I don't think a machine can be designed uh, for things that humans do very naturally. Like, for example, intuition. Sometimes what you hear, gut feeling, right? I have a gut feeling how this is going to operate. Machines don't know that. Machines are designed by humans to be very methodical. If this, then this, else that. And so it's going to be obviously a combination of machines getting smarter because we have more technology, faster machines, more computing power, and all that. But then the human also is going to become more intelligent on how to use this technology. And so there's something that we do at NASA and starting to do a lot more because of the complexity of some of these systems is that we now not only have what we call technology readiness level. What does that mean? That means is how mature is this technology ready for use by humans? And then secondly, we call human readiness level, which means how ready is this technology ready to be used by a human? And so we have these merging of technology and the human and checking to make sure that everything is going to work properly between the two. You hear about automation of cars that drive by themselves. And I don't know if you've heard of what happened in here in the United States with Tesla. I think there's been a few deaths because the car was in the autonomous mode, automatic mode, and it crashed because it failed to recognize something that the system did not know. or did not understand what it was, and it crashed right into a truck. And one here in Houston crashed into a person's backyard, and went inside the swimming pool, and one person died. So technology, you got to be careful with. You cannot be fully dependent on it. You always have to have the human, what we call human in the loop, always looking at the technology, and maybe we can let the technology fly itself, or if it's a sailboat, sail itself and things of that sort. But the system should always be designed to let the person some person know that, hey, something's wrong. I can't control this. Please take over. And that's important. And that's what we're planning for future space missions, is automatic, autonomous systems, but they will always be under watchful eye by the astronauts to make sure that they're always operating properly. You cannot take for granted that they always operate properly, because things can go wrong, especially in the space environment. One of the big things in space is radiation and how it affects electronics. And so what can happen is the electronics can start to hiccup, as we call it, and start doing wrong things that they're not supposed to be doing, because the radiation, space radiation, upset the electronics. So we always have to be cautious about that. Even now, space station and SpaceX, in fact, they experience what we call radiation effects, but they know how to get around it. And the reason why it's not too bad is because we're under the Earth's magnetic field, and the Earth's magnetic field protects us a lot from radiation, bad radiation. Once you get outside of there, like we go back to the moon and even Mars and beyond, radiation gets really bad. So we have to be very cautious about
If I were you, I would blame it on the aliens and get away with with responsibility. uh,
that.
and that's what we usually do. It's easier. My last question is, Mr. George Salazar. There's so many people in Pakistan who are brilliant at engineering, who are great at maths, but they undersell themselves because I know they think they're not good enough because of their struggles, because they think they're not coming from a certain background. So, how would you encourage them to pursue STEM career?
Uh, well, okay, so just an example of myself. I was not a very good student. In high school, I graduated. There were 605 students that graduated in my high school class, and I graduated number 475 out of 605, which means I was at the bottom 20% of the class. Um, when I wanted to go back to college, I took what they call the Scholastic Aptitude Test, and you have to score, certain grade in order to get into a university. And I scored very, very low, but I was able to find a way to get into what we call a 2-year college, and I got a degree there. And then I transferred over to the university and got my bachelor's in electrical engineering. But I also saw, and maybe that was very good, that I saw, my grades were all fantastic, and so I worked also doing hands-on electronics. I worked as a repair technician for Canon calculators, and then I also did some internships with a seismic exploration company. And so that got actually my job at NASA. I never thought I was ever going to work at NASA. I had applied at NASA when I was a student as a what we called an intern, but I got declined because my grade point average wasn't high enough. So this company called Geosource did take me working as a engineering technician in it was a combination of hands-on experience and to some extent grade point average. I have to say that grade point average doesn't measure things about the student. I'm an example. It doesn't measure uh, uh, how let's say, the strength of your perseverance of wanting to do something, to be somebody. There's no test that measures that. You can have a grade point average, and I know some people that graduated with me that were 4.0, perfect GPA students, but yet they never designed anything. And I got four patents under my that I've gotten over the years, and so it's a measure of how bad you want it. Now, for many of the students out there, they say, "I want to come work for NASA," and that's a challenge because usually NASA and a lot of the contractors require the potential employee to be a U.S. citizen. And so let me share a story with you real quickly about a young lady from India that we became friends, and she was in high school at that time, and she wanted to come work at NASA. And I told her it's going to be a challenge. She says, "I don't care. What is it going to take? What's it going to take?" And I said, "Well, look, get a bachelor's degree in India, and then go for a master's. Come to the United States and work for a master's degree." And then afterwards, find yourself a university that has professors that work with NASA and work with that professor. So that way, people at NASA get to know you. Well, this was about, oh gosh, now it's about 8 years ago. Well, she's in the United States now. She got her bachelor's, she got her master's from Syracuse University in Newark, here in the United States. She's right now presently working on her PhD at Stanford University in California, and she potentially found a professor that's working NASA projects. So it's been a long road for her, but it if you have the determination and you have the will, you'll find a way.
Indeed, and thank you very much for your time and for superb advice to me, myself, and all the people who will be watching this. So I'll just officially